Today we are going to do these topics. Firstly, we are going to learn what a multidimensional array means. Then we are going to look at what pointers and multidimensional arrays relate to. There is a relation between pointers and arrays, so there is a relation between pointers and multidimensional arrays. Okay, what happens if I declare an array with like this A5? This means that this is an array which contains 5 elements. So what happens is 5 elements of memory is stored and it is numbered from starting from 0. So 0, 1, 2, 3 and 4. So this is a normal array which we have seen in previous lectures, right? And we index that array using a subscript. So if you want the first element, that is the 0th element, you access it using A0. Now this index which we have used, that is the method of accessing the elements of an array which we have used, is called an index. It is the dimension of an array. So this type of array has only one index. So the dimension is only 1. This array has dimension of only 1. That is, it is a linear array. We have a list and we number the list starting from 0. But you can also have an array which looks like a matrix, which can have more than one dimension. Let's say I have a matrix like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 elements. Now what you can see are two-dimensional arrays. It is because this array has 2 dimensions. One is rows, right? This is first row, second row and third row, and other, which you can guess, is columns. Rows and columns. So such type of arrays which have 2 dimensions are called as two-dimensional arrays, or more than one dimensional arrays are called as multidimensional arrays. So we can declare this array like this. Let's say the name of our array is A, and we have the rows index and the columns index. So here how many rows? 0, 1, 2. That means 3 rows. And columns are 0, 1, 2, 3 columns. So you see it has 2 dimensions, right? So this is a two-dimensional array. Okay, now many a times in our life we have this situation, right? Roll numbers and marks. So we have rows and we have columns. Now this is essentially a matrix, right? This is a matrix, and a matrix is nothing but a 2D array, a two-dimensional array. Okay, it has columns starting from 0, 1, 2, 3, 4. So it has in all 5 rows. Now what you can see is if you can club each row, if you can separate each row. So this is one row, this is another row, this is the third row, this is the fourth row, and this is the fifth row. Now what you can see is an array of rows, right? Array of rows, and those arrays, those rows in turn are nothing but arrays like this. This is the first array, 1055. This is the second array, 575. This is the third array, 995, and so on. Now what you have seen is nothing but array of arrays, and these are 1D arrays, right? Array of 1D arrays is nothing but a 2D array. Okay, let us see how do we declare arrays. So let's say I want to declare a 2D array which stores integers. So similar to 1D arrays, we declare the type of the array, each of the elements which are stored in the array. Then we have the array name, and then we have dimensions. Let's say I have 3 rows and 2 columns, right? So similar to 1D arrays, we have the elements. So what we've seen before is that a 2D array is nothing but an array of 1D arrays. So let's declare each of the rows. So the first row is 10, 55, then a comma, that is the next array now, 1055, 575, the next array now, which is 991. Okay, so we have our 3 rows complete, then a closing brace, then a semicolon. So this is how you declare and initialize arrays. Now one thing I want to tell you is that this dimension is optional while declaring and initializing. Now this is optional while you declare and initialize an array. Why this is optional? Because this is rows and this is columns. Now rows are optional because the compiler can automatically determine rows if it knows the number of columns. Because you have the total number of elements, now it partitions the elements according to columns. Now it partitions two elements and finds out that there are 3 rows. Okay, another way of declaring and initializing array is like this. Let's this time leave the rows optional. So arrays A2 is equal to, then straight away initialize the elements like a 1D array, and so on. So we can initialize it like this, but it involves loss of readability, right? And this is a bad technique. Use this technique only to declare and initialize arrays. Okay, we studied that an array and a 2D array is nothing but a matrix, right? So a matrix is a 2D array. Let's write a program that adds 2 matrices. So we have one matrix which stores one 2 by 2 matrix, which let's say stores 1, 2, 3, 4 as its element. We are going to add it with all ones, and then we are going to store it in some other matrix, that is the result. So we'll have to declare the first one, the second one, and the third one. So the first one is 2 by 2, right? Let's name it A. The second one is also a 2 by 2 matrix. Let's name it B. And the third one is the sum, which is also going to be a 2 by 2 matrix. Now how matrix addition occurs, you may know that the first one is added with first, the second element is added with second, third element is added with third, and the fourth is fourth. Right? This way matrix addition takes place. So let us write a program for matrix addition. So I have written something for you already. We have the main function and we have included the standard input output header file. Let us declare the first array int A, which is a 2 by 2 matrix. So 2 rows and 2 columns. Let us initialize it is equal to and the opening brace. So we have the first row as 1 and 2, then comma for the second row, and 3 and 4. This is the second row. After the second row there is no row, so we don't have to put a comma there, and a closing brace and a semicolon, so that the declaration and initialization is complete. Let us declare the second one, B, which is also a 2 by 2 matrix. Let us initialize it again here, and we have all ones in this array, in this 2D array, comma 1 and 1. Okay, so we have declared and initialized two of our variables to be added. Let us declare the sum so that we can store our result of addition. So int sum, which is a 2 by 2 array, 2 rows and 2 columns. Now what we will need are index variables. So int I and j. This time we are going to need 2 index variables because we have 2 indices, the row and the column. So these are index variables. Okay. Now to add, what we have to do is to first select a row and then select the respective column. This way we are going to select each of the element. So first thing we have to do is to select a row. So first select the row one by one. How you are going to do it is using a for loop, because there are 2 rows and we'll have to run the loop 2 times. So for I is equals to 0 and I is less than what? 2 and I plus plus. Inside the for loop we have now selected a row, then we have to select the column so that our element is selected. And then select the column of this row, right? So there are 2 columns, so we'll need another for loop. For this time j, we cannot use I because I is in use in the first loop. For j is equal to 0 and j is less than 2, because there are 2 columns, and j plus plus. Okay, we have selected each of the elements in these 2 for loops, right? So we are going to store in sum the addition of A and B. So let's select each of the elements of sum. So first the row I and then the column j. As it is in a loop, this will get executed for all of the elements for sum, for A and for B, right? For sum ij is equal to aij plus bij. So one by one we are going to select each element of A and B, add them up and store it in its respective position in sum, in its same position, right? So this way we are going to add up the sum. Okay, now addition is done. What we'll have to do is print the result. So we are going to say printf the result is, and we are going to print the 2D variable sum. Okay, let me scroll a bit. Okay, so our sum is a 2D array, right? So to print it, we will have to access each of the elements of sum. And to access each of the elements of sum, we will need loops, and this time 2 loops. It's the same way which we have done before for a 1D array. We have selected each of the elements using a loop. So this time, as it is a 2D array, we are going to use 2 loops. So let's select the row first. So for I equals to 0 and I is less than 2, I plus plus. This is done. Then select the column for j equals to 0, j is less than 2, j plus plus. Column selected. Now printing the elements of this row one by one through columns. Printf %d and then a space so that it aligns up properly. %d and the element of sum. So sum I and j. Selecting the row and then the column. When the control comes here, that means the row is printed. Let us make things better here and print a new line so that it comes to the next line when it prints another row. So print \n so that it gets better here. We have our program now ready. Let us run this program and check is it correct or not. And the result is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 4, and 4 plus 1 5. So this way you write programs for 2D array. Remember, to access a 2D array you will need 2 indices, and for 2 indices, to access the elements you will need 2 loops. So a loop, first loop to select a row, and then the second loop to select the column. Okay, now what we know is that a 2D array is nothing but an array of 1D arrays. Okay, so we have this array, 2 by 2 array, which contains 2 rows and 2 columns. Now this is nothing but one array and second array. So 1, 2, this is the first array, 3 and 4, this is the second array. So array of arrays. Right. So what we are going to do is to learn how do a 2D array gets represented in memory. So we have an array, right? Array of arrays. So an array is represented linearly in memory. So this is represented like this. So we have our memory, the first element 1, 2, 3 and 4. The first array here, then the next array, then the next array, then the next array. So in the first array the elements, in the next array its elements. So array by array it is laid down like an array. If you don't understand, this element is A00, right? 0th row, 0th column. So this is 0 0. This is A0 1. This 3 belongs to A1 0, and this 4 belongs to A1 1. Okay, now what you have learned is memory has addresses, it has locations. Let us say that this first location is 100. Okay, so how do the next locations get their address? So first is 100, an integer is 4 bytes long, so the next would be 104, the next would be 108, and its next would be 112, 112. So this way 2D arrays get represented in memory. Now you can easily determine that it is almost the same as a 1D array. In fact, 2D array is an array of 1D arrays, so eventually it is an array, so it is represented like a 1D array. Okay, it's the time to learn about pointers in association with 2D arrays. Now what we learnt in 1D arrays is that if we have an array of 5 elements, A will give the base address. Right? A will, by saying A, we get the address of the base element, of the 0th element, the first element. Okay, so a while before we learned that an array is a 2D array is an array of 1D arrays. So we have array of 1D arrays. So 1, 2 is one array, 3, 4 is one array. So this array is the 0th one. This is the 1th one. Right? Same. If we have numbers 0, 1, 0, 1, 2 and so on, this way this array is index 0. This array's index is 1. An array inside the 2D array, each row is also treated as one element. Consider it as one element. So this is the name of this array. A1 is the name of the 1th row, right? The 1th array. So what will A0 give us? So the name of a 1D array gives the base address. So this is in fact the name of the 1D array, right? A0 refers to the 0th 1D array. A1 refers to the 1th 1D array inside the 2D array. So this is in fact the reference or the name of the respective arrays. So this will give nothing but address of the 0th array, and this will give address of 1th array. 1th array means the 1th row. Okay. So let us now associate this with pointers. Now to get the, let's say we have the first one, the second one and the third one. So we have 1, 2, 3, 4, 5, 6. So we have 3 rows in our array and each row contains 2 elements. So to access 1, what we'll have to do is star of, right, value of A0. That is the value at the 0th array, value of the base address of the 0th array. To access 3, we will have to do value at A1. Right. To access 5, we will have to do value at A of 2. I think it is making some sense now. Okay, let us clear this up and try to determine the value. How do we determine the value of this element? The second element in the first row. So value of A0, that is the 0th row, and the column is we have to increment our pointer to the next address. So this is one ahead of the base address, so 1. For 2, value of A1 plus 1. So this way we access the elements of a 2D array using pointers. Okay, what happens in a 1D array when I say A of 5? I want to access the 5th element, the 5th element of the array. So using pointers we have the value at, then the base address, and we have the 5th element. so we add it 5. So this is in case of the 1D array. Now we had a 1D array here also. So to say a of 1 plus 1, we are taking this example, a of 1 plus 1. We have the value of a of 1 plus 1. So how can we get, using, if we want to get rid of this a of 1, if we want it all base address and pointers, we can do it like this. Star of, now this a of 1 can be done like this. A of 5 can be star of a plus 5. So a of 1 will be star of a plus 1, and this plus 1 goes here. So this way you access the element of a1 1. So to speak, aij will be accessed like this. Star of value of then a plus the row, then we get to the column. Okay. So to understand this concept more clearly, let us take another example. Let's say we have a 2D array with 4 rows and 3 columns. Right. Now we have 4 rows. So 0, 1, 2, 3. I'm missing a row here. Let me draw a row here again. So 4 rows and 3 columns, 0, 1, 2. Okay. Now what we have is, we want to access this element, this 9 element. It resides at the coordinates 2 and 2. That is, to access it we will use p2 2 using the standard notation. Now if you want to use pointers, you have to do it a different way. But to understand how pointers work, we'll look at it like this. Now just saying p will give us the base address, right? The base address. So p is nothing but is nothing but the pointer to this array. That means the pointer to 0th row. Pointer to 0th row. That is the base address. It points to the first element of this array, and the first element resides in the 0th row. So this is p. P points to 0th row. Now to access the next row, we will have to increment this pointer. Right? This is p plus 2 and this is p plus 3. Now when you this pointer points to a 1D array. So incrementing this pointer will point to the next array, not the next element. It will point to next array. Similar to when we increment an integer pointer, the pointer points to next integer. So if you increment a pointer to an array, it will point to the next array, right? Not the next element in the array, it will point to next array. Okay, now this is p plus 0. So the standard notation here we get is p plus I. There is nothing but p pointer to ith row, right? Okay. Now you have the pointer to the row, right? Now to get to the element of a particular row, we will have to get to the first element of that row. Then we can increment our pointer to the required position, right? So p plus i's value, if we get its value, we will move our pointer to the first element of that particular row. So this is value at p plus 2. Right. Now what we got is, this is pointer to 0th element of ith row. So this way it is. Now you have to get to this number. Now how far away is this number from the 0th element of this row? So we will have to increment the pointer by 1 and 2. So p plus I plus j will give pointer to the jth element in ith row. Right. So we have the pointer like this. Value at p plus 2 means the pointer to the base element of this row, and we increment it until we get to j. So j is 2 here. So we have the pointer. But to get the value 9, we will have to use the value of operator. Well, this will yield us 9. So this way we implement pointers using 2D arrays. So to give you a formula, if you have something like p of, let's not use p, let's use a of 3, 2. So you have to access the element which resides in the third row and the second column. So this will be, first you get to the row. So value at a plus 3. So first you get to the row, then to the column, so plus 2, and then you have the pointer, so you access the value using the star operator. So to summarize, to make it more generic, we have the notation like this. A plus I is the row, let's not use I, let's use R, and plus column. So this is the general notation of pointers and arrays. Okay, now let us understand how do you assign the base address, how do you equate arrays, how do you assign the value of one array to another array, because this is important when you use pointers and arrays. So you have one array which is a 3 by 3 matrix, and you have some data here, right? So let us put it this way. What you have to do is to assign this to this array, the value of this array. So assign p, which is essentially a 3 by 3, which has to be a 3 by 3 because you have to equalize two matrices. So is equal to, if you say a, now p is a pointer, right? P gives base address, so p's base address is replaced by a, which is essentially the base address of this array 3 by 3. With this, let us write a program which does nothing but prints an array using pointer. So when you assign, you actually assign a pointer. So let us write our function, which soon we are going to write in our compiler. The name of our function is print 2D array. It returns void. It does not return anything. Void print 2D array. This is the name of our function. It accepts an integer array. Let's name it p, which is a 3 by 3 array. Now I'm telling you that it accepts a 3 by 3 array. In fact, it will accept a pointer like this. It will only accept the base address and assign it to p. And we have int r as rows and int column as column, so that we know what do we have, what are our boundaries for this array. So let us jump to our compiler and write the prototype for our function. The prototype declaration. It returns void. Its name is print2d array, and it accepts an integer array, which is essentially a 3 by 3 matrix of 2D array, right? It is a 2D array, and it accepts rows and columns. So this is the declaration of our array. Okay, now in main we just declare randomly some array arr 3 by 3. Make it a habit that you always give dimensions of your array while you declare them. Even if you initialize them, do give dimensions to your arrays because it makes more sense. So let us randomly put some elements in our array, which is a 2D array, 4, 5 and 6. Oh, I missed a comma. So 7, 8, 9. This time we don't need a comma because this is the last row. Okay, we have our array. We just have to print this array using a function. So this part we are going to pass a 2D array to a function. So print 2D array, and we are going to pass it our array arr. So in fact we are going to pass the base address, right? Arr, and we are going to pass the rows and columns. How many rows does our array has? 3, and the columns are also 3, semicolon. So we have made a function call here. You know this. Let us write the function definition, the function print2d array for this program. Void 2d array, and we have the pointer p3 by 3 r, and we have the column. Okay, now what we are going to do here is printing this 2D array which we receive as an argument in P. Now essentially what is getting passed is a pointer. ARR gives us the base address, so the base address is going to get stored in P. In P's base address of ARR is going to be stored. Okay, now let us declare index variables for us to use. Now you print it, you access the element and print it in the same way we did in previous just a while ago. So for I equals to 0, let me pause the video and write it for you quickly. Okay, I have written the same thing which we did in just a while ago. I have accessed the rows first using a for loop which runs from I equals to 0 to R, which is essentially 3, and then the columns which run from 0 to C, which is essentially 3 also. So here we are just going to printf each of the elements of our columns. So printf %d, then a space, and you can do it this way, P, I, and J. So this is the simplest form of using arrays and functions. And let us print a new line after each row is printed. When the control comes here, it means that it has printed one row. So let us print a new line. Let us run this program. So our program is running perfectly. Let us this time change something and print it using the pointer notation. Now I am again telling you that essentially what has been passed is just a pointer. That's why I have named it P. Though I have not used the pointer notation star and address of, but ARR, an address is passed, base address, and it is collected in P. So P is essentially a pointer. So let us print this array using the pointer notation. So first we get to the row, right? So P plus I. We use the value at address to get to the row. So we have gotten to the row. Then I'm talking of this statement here. First we get to the row using the P plus I. That means we have got to the ith row. Then we get to the respective column of the ith row. So plus J. And to get the value, use the value at address operator. So this way we have used the pointer notation. Let us run this and check if our pointer notation is correct or not. And indeed it is correct. Okay, we do have 3D arrays also. I mean, multi-dimensional arrays, you can have as many dimensions you want in arrays. So 3D arrays is nothing but an array of 2D arrays. And 2D arrays, we know that it is an array of 1D arrays. So I'm not going into details of the 3D arrays here, but you should know that a multi-dimensional array is an array of some array, right?